In this problem, written twice the same problem, we have a complex fraction, but we have subtraction of fractions in each of the numerator and denominator of the complex fraction. Now, what should we do first now? The order of operations will help us decide. The fraction line is a division problem, and it's a grouping symbol for division. So the grouping symbol says basically complete what's in the numerator if you can do anything there, complete what's in the denominator if you can do anything there, and then do the division last. So what we've really got here is a case where we have to do the subtraction in each case first. So we'll look at that, and we'll see that if we have x and x squared as denominators, that means we have to multiply this one by x over x. And when we do that, we'll wind up with 6x minus 12 all over x squared. That's our first fraction. Now we'll do the same thing in the denominator. Here we have x and x cubed as a denominator, so we'll multiply this one by x squared, and we'll wind up with the fraction, and we'll divide it by, we're using that now, 3x squared minus 12 all over x cubed. Well, what we'll do now is write each fraction in factored form. We can do some factoring here. And we'll factor them and invert so we can multiply. Let's see, this will give us 6 times x minus 2 over x squared times, so we'll put the x cubed in the numerator, and then we'll factor this and get 3 times x squared minus 4, but that's x plus 2, x minus 2. So there's our product. Well, we can cross out the x minus 2's, and we can cross the 6 and 3, leaving behind a 1 and a 2. And we can cross out the x squared and the x cubed, leaving behind an x. Wow, if we can find out what's in there, we'll have our answer. 2x over, there it is, x plus 2. Can I cancel the 2's? No, this one's a factor, but this one's a term, so I'm not allowed to do that. Well, there it is, done by division. First you have to do the subtraction, and then the division. Well, let's try this second problem and see how it works out. We want to multiply everything by some least common denominator of all the denominators in the problem. There's x squared, there's another x, there's x cubed. What's the common denominator? The common denominator is going to be x cubed. Okay. So if it's x cubed, we'll have to multiply x cubed. We're going to use the distributive property on this. So if we multiply x cubed times 6 over x, we'll end up with 6x squared. And then if we multiply 12 over x squared times x cubed, we'll cancel that out, and that will give us minus 12x. And we're done. Now let's look at the bottom. If we multiply 3 over x times x cubed, we'll have 3x squared. And negative 12 over x cubed, the x cubes cancel out and leave us with negative 12. So now we have a simple fraction, but we don't know whether it's in lowest terms until we go ahead and factor. So we'll do that, and looks like we can factor a 6x out here, leave us with x minus 2. And here we'll pull out a 3, And we'll get the same factoring we had before. 3 times x squared minus 4 is x plus 2, x minus 2. And we'll see that we can cancel out the negative 2's. We can cancel the 3 and the 6. And we'll wind up with the same answer. 2x over x plus 2. So you have these two methods. You can either combine the numerator and denominators when necessary and do division, or you can multiply through by the least common denominator of all the terms in the problem and do whatever is necessary after that to combine terms and factor and reduce to lowest terms.